Hey there. Didn't see you there. I was just admiring the nature. Speaking of nature, have you heard about the Alps? We are Group 3 of Adelfa, and we're here to tell you all about the Alps. But before we talk about the Alps, wouldn't it be more interesting to talk about its formation first?
With this, let's start with our friend Alfred Wegener. He theorized the continental drift theory and a part of the theory, the Pangaea. The Pangaea is essentially a supercontinent that originally contained almost all of the land on the Earth. Then, the Pangaea broke into two main parts, the Laurasia and the Gondwana.
So now, based on Miguel, we already know that the Pangaea is split into two parts, the Laurasia and the Gondwana. However, what exactly caused these to break apart? Well, in plate tectonics, there's a concept called the convection currents, wherein the currents are formed due to hotter magma sinking and colder magma rising inside the mantle, thus causing currents. Now, let's talk plate tectonics. So we can imagine the Earth as a bunch of plates that are connected to each other. Now, these plates have small gaps in them, which allow them to move a little bit, but these little movements eventually cause a lot of damage. So imagine this. Now, the convection currents are constantly like a conveyor belt moving these plates. And let's say, for example, in this illustration, they eventually split apart like very much in a span of a long period of time.
After drifting apart for quite a long time, part of the Laurasian and Gondwana, namely the Eurasian and African plates, collided again. This formed the Alps. With this collision, we get a convergent plate boundary. There are two possibilities, subduction zones or collision zones. Subduction zones are when a plate goes under another plate. Collision zones are when neither of them can subduct, since neither is significantly denser than the other, and they will just collide with each other and create an extrusion, usually in the form of mountain ranges. In between the two plates, Laurasia and Gondwana, is the Tethys Sea. The Tethys Sea has been collecting sediments and minerals. When the African and Eurasian plates collided, not only did the two plates push together, but so did the sediments in between them. As they pushed against each other, they created folds of rock and eventually an awesome mountain range. The napes, or sheets of rock in the Alps, are divided into sections by geologists. There are three main zones, the Helvetic Zone, Pennic Zone, and Austral-Alpine Zone. These sediments were originally deposited in the Western Alps, Tethys Sea, and Eastern Alps respectively, where they were then compressed to form zones.
These zones explain a lot about the geological structure of the Alps, such as what minerals may be found in each region, or why a certain region has taller peaks than the other.
Finally, the current wonders of the Alps. The Alps is a high snow-capped mountain. This is found in South Central Europe and is known as the highest and most extensive mountain range system on Earth. It stretches around 750 miles, which is almost 1,000 kilometers long. It passes across France, Switzerland, Monaco, Italy, Liechtenstein, Austria, Germany, and Slovenia, spanning from west to east between Genoa and Vienna.
The Alps have various species of animals and plants. The Alps also provide a good source of fresh water. The European Alps are a common tourist site because of the incredible view, thus tourism. The cultures of farming, cheesemaking, and woodworking still continue to thrive in the Alpine region.
Right now, the Alps is stable in terms of tectonic activity, which means it probably wouldn't just suddenly disappear. However, it's still not stable as though the Alps is now suffering melting glaciers due to global warming. Yeah, our enemy, global warming. Anyway.
The Alps are quite a beautiful and interesting geological phenomena. However, we are destroying these beautiful natural creations through excessive activities that ultimately destroy our Earth. We must preserve this wonderful Earth for even more generations to experience these wonderful geological creations.
This is Group 3 of Adelfa
Signing
off.